Hi, thank you for attending this session. I am Monte de Jesus, Senior Threat Hunting Engineer from Trend Micro, and in this track, I will be sharing with you guys our current threat hunting process. Currently, there is no one definition of threat hunting, since threat hunting have a broad scope and there are a lot of methods, tools, and process in implementing threat hunting. But according to awakesecurity.com, threat hunting is the process of an experienced cybersecurity analyst proactively using manual or machine-based techniques to identify security incidents or threats that are currently deployed automated detection method didn't catch. So in Trend Micro, there are two kinds of threat hunting. One is hunting threats within the environment, which is handled by our XDR team. Using automated and manual correlation of data across security layers, they hunt for incidents within the customer environment. And the other one is hunting for incoming potential threats, hunting for new threats in the wild before they reach customer environment. In the next slides, we will be discussing the process on how we do threat hunting for incoming potential threats. In this slide, we will be discussing the process overview to give a bigger picture on how we do things. First is we collect the indicators of compromise, or IOCs, from different sources like VirusTotal, Honeypots, open source intelligence, blogs and news, Twitter feeds, and internal intelligence from Trend Micro. Initially, we found a new source. We first verify the quality and intelligence if they are duplicates from other sources. Are they mostly malicious? We would like to avoid having normal samples in our pool to avoid not only noise in our data but also wasting processing power and time. We also want to identify any other important metadata that we may want to keep, like tags or rule hit, which may help us give identity to a hash. After verifying the source, we assess if we can provide automation and then move on. All of the collected hashes are then submitted to our system and go through a series of modules that creates a profile or identity to a given hash. Modules include sandbox, metadata extraction, clustering, trend micro solution, goodware check, and machine learning modules, which I will be explaining in more details later in our slides. All of our collected data are then sent to our database. We are currently using Elasticsearch on our backend and Kibana as our user interface. So here's a short list of what we're currently using as sourcing channels. Open source intelligence, VirusTotal, Twitter, Honeypots, blogs and news feeds, and internal intelligence. Actually, there's a lot more on our list, but most of them falls under open source intelligence category. VirusTotal could be considered as an open source intelligence, but we will be discussing it more since it have more capabilities when using the enterprise version. According to Wikipedia, open source intelligence, or OSINT, is the collection and analysis of information that is gathered from public or open sources. Here are some websites that we are using and already added to our automations. Malware Bazaar. Malware Bazaar contains a collection of malware samples submitted by researchers. This site contains metadata on the uploaded samples as well as Yara rule-based signature hits that helps identify the related malware family. It also have additional information or behavior reports from other security vendors. You can submit, download, or query their site using the web interface or using its APIs for accessing data programmatically. Another example is URL House. The site contains reported malicious URL that leads to possible payloads. The site contains metadata on the reported site like tags, status if it's online or offline, the submitter. You can submit, download, or query their site using the web interface or using its APIs for accessing data programmatically. Both of the mentioned sites are maintained by abuse.ch. Next is Hatching Triage. Hatching Triage is a malware analysis sandbox that have cross-platform support. It contains tags relating to a malware family. It also have a behavior-based reports and malware score that range from 1 to 10. You can also query their site using their web interface or using its APIs for accessing data programmatically. Related malware hashes harvested from these sites are submitted in our system for profiling and analysis. Lastly is the Azurel Tracker. Azurel Tracker is a malware tracker centralizing in Azurel C2 panels and monitoring them for threat hunting purposes. The site contains information on the command and control index, number of victims, top victim country's IP, autonomous system number, and also the status of the C2 index. Other information are available such as behavior, stealer capabilities, and some have related binary information. Most of the URL sources have no related binaries, but we will discuss it on how we leverage the given C2 panels to collect the related malware binaries. VirusTotal. We can say that it is one of the most useful resources not only to a threat hunter but most of the individuals working in the security industry. You can have access in both free and paid services. Free users will not be able to use its full hunting potential and will have limited number of requests per minute. We will be covering some of the features of VirusTotal that we find very useful for hunting, and these are VT Web Interface, VT Hunting, and the VT API. Here's a view of the paid web of VT. I think most of the attendees are familiar with this. Here you can submit URL or files for analysis. Also, you can query multiple hashes for hunting. The free version only supports one hash per query. There are also numerous search modifiers that could be used to filter your search to specific results. For example, limiting samples to a certain size, submitted date, file types, and positives. This is a great tool if you're looking for specific malware and other related IOCs if you are following a malware campaign. However, this feature is only available to enterprise version. VirusTotal supports hunting based on Yara rules. You can deploy rule sets using string-based rules, behavior, and VirusTotal identifiers. These features available in enterprise version. You can deploy multiple rule sets and set the email address where the result will be sent. Here are some of our deployed Yara rule sets. The first one is the Azurel rule set. This rule is based on the behavior logs. It looks for any related HTTP conversation that is related in the listed C2 URLs. These URLs are the one that we have found in the Azurel tracker page. We have harvested all of the related C2 index and applied it in VT deployed the Yara rules to be able to source Azurel related binaries. Another Yara rule is a very simple one. It looks for files that contains the string crypted by Cassandra Crypter. The string is present in files that uses Cassandra Crypter, a service that provides FUD or making malware samples fully undetectable. There are a lot of Yara rule repositories that are available in the internet that you may use depending on the target malware family. Especially searching for files that you have a limited information like file name, a string, or a hex byte in its code. Yara hunting is in real time, but you can also deploy your rules in RetroHunt to search for files in VirusTotal database. However, only pure Yara rules works in this feature. VirusTotal API. Using VirusTotal API, you can upload, scan, query, retrieve hunting results programmatically. This is a great help in integrating our hunting results directly to our profiling module without human intervention. There's still a lot of functionality and features that we can explore in VT. We barely have scratched the surface. It is a great place to start in hunting for malware IOCs. I suggest for interested participants to explore more on VT's capabilities. Now moving on to the next source. Okay, for finding and reading for the latest threats, we look at Twitter feeds. This is where researchers post the latest malware IOCs, analysis, discussion, and sharing of useful news and blogs. It is already my daily routine to read my Twitter feeds using TweetDeck, where you can easily browse feeds and read through topics of interest. Most of IOCs is shared by researchers before a write-up or a complete analysis is created. We can use this as a reference on what is trending and cross-check in our intelligence feed. It also helps us see if there's an ongoing campaign on a certain sector or region. Collecting IOCs programmatically is also available via API. Continue monitoring and adding of new personas to follow would help us to enrich our hunting. Okay, a honeypot is a sacrificial computer system that is intended to attract cyber attacks. A spam trap or email trap is a kind of honeypot that harvests the spam emails. We receive email samples from spam traps. These email samples are sorted and then the attachment from malicious emails are collected and submitted to our profiling modules for analysis. We can say that email is the most common method of malware delivery. It's vital to collect information on what kind of possible exploitations attackers are going to use to be able to execute code on the victim machine and successfully execute a malware on the asset. Lastly is blogs and news feeds. There are a lot of feeds and blog sites that you can read. They may contain insights, complete analysis, predictions, tutorials, new tools, etc. Here are some of the news sites that is noteworthy to monitor. Trendmicro.com for complete report overview. Trendmicro reports usually covers analysis, impact, new techniques, solutions, and recommendations. It is also a great way to be kept updated on what are the latest discoveries and researches by our colleague. Next one is zero2auto.com. Blog entries in these sites contains in-depth analysis of discovered malware families. They share some of the tricks and methods in reverse engineering malware samples to uncover functionalities and have a general idea of malware capabilities and sometimes discovering clues that may lead to malware actors. They also discuss tools and resources. This is a great way to learn new approach in reverse engineering. Last one is bleepingcomputer.com. Bleeping Computer News posts a lot of news daily. Most of them are fresh and also have great initial analysis. They not only focus on malware-related reports but also on other security-related news. Hunting through news and blogs usually is for some supplementary information. We don't usually have a specific following on news outlet on a daily basis, but instead reading on sites that publish news of interest or hot topic. Some of these are already shared in Twitter. Internal intelligence. Internal intelligence are information within the organization that could come from news banks, wiki pages, research papers, unpublished informations, and work groups. These informations are sometimes trivial, classified, or a lead for an ongoing campaign that requires special attentions. Sometimes these informations are sensitive enough not to be included in our pool of data. Profiling. Profiling is the collection of data from source sample. Collection includes intrinsic and extrinsic metadata. It includes the following modules: sandbox, machine learning, trend microsolution, metadata extraction, normal file scanning, and clustering. In collecting metadata, here are some of the info that we collect: file size, file type, XAPE info, which determine the compiler or any identified packer, the hashes, the submitter, the source, and tags. Through the years, Trend Micro have an enriched normal file database. Verified normal files, application, Windows components, and other partner companies are added to the database, including new version components. Collected samples are scanned if they already exist in our normal DB. All results are sent to our backend database. All collected samples are scanned using the latest Trend Micro conventional pattern and machine learning model. This will help categorize and prioritize sample processing. This will determine samples if they are currently supported by the latest Trend Micro solution, and if not, submit it for analysis and detection. Machine learning modules. Currently, we have two machine learning modules. One is the document macro script, detects anomalies in macro scripts embedded using machine learning models. This module extracts macro scripts in documents and scanned against a machine learning model, which helps us determine if the file is malicious. Precise malware naming gathers file metadata and feed it to a machine learning model to determine the precise malware family. Another one is the trend locality sensitive hash for clustering. It identifies near duplicates and similarity based on source code. This is very useful in the area of computer security, where it is required to identify malware samples with similar binary file structure. This will help in creating a file cluster for faster analysis, data correlation, and malware family identification. Sandboxing. Filtered samples are executed in a custom sandbox powered by Cuckoo. Cuckoo Sandbox is a free software that automate the task of analyzing any malicious file under configured environment. Sandbox results will produce a detailed report outlining the behavior of the file when executed inside the realistic but isolated environment. The behavior logs are collected and scanned using Yara engine to determine malware family based on behavior signatures. All of the results are sent back to Elastic database. I mentioned that only filtered samples goes through Sandbox since it takes a lot of processing power and given a certain amount of running time. This may cause bottleneck in operation if a lot of samples will be going through the Sandbox process. Data keeping. All of the results collected from different profiling modules are sent to Elastic database and explored using Kibana. So what is an Elasticsearch? An Elasticsearch is a distributed open source search and analytics engine built on Apache Lucene and developed in Java. Elasticsearch allows you to store, search, and analyze huge volume of data quickly and in near real time and give back answers in milliseconds. It's able to achieve fast search response because instead of searching the text directly, it searches an index. It uses a structure based on documents instead of tables and schemas. It comes with an extensive REST API for storing and searching the data. In my experience, it is easy to set up and just download it, unzip, and then execute. Then Kibana is an open source front-end application that sits on top of the Elastic Stack, providing search and data visualization capabilities for data index in Elasticsearch. Commonly known as the charting tool for the Elastic Stack, Kibana also acts as the user interface for monitoring managing, and securing an elastic stack. We can query data using Kibana query language to find specific informations. For example, I'm currently following a campaign related to Avadon ransomware. I can look for hits from deployed Yara rule in VirusTotal. I can look for new samples not supported or properly identified as a ransomware. We can now query any information from our source samples using previously extracted profiles as an identifier. Another use case is creation of graphs to determine the threat type distribution. By creating graphs, we can have an overview of our data on a given set of time. Using Kibana, we can also create a dashboard that contains combination of predefined graphs and tables. This helps easily observe desired information and transforming them into actionable intelligence. Another use case is us creating a histogram or for the identified malware families. This will help easily identify the trend based on current detection, predicted family, or other indicators. It is also used in identifying the number of undetected threats that needs further analysis and could lead to discovery of new malware families or techniques. Okay, let us summarize what we have discussed today. We have discussed our overall hunting process from data gathering, transformation, and interpretation. We have cited some examples of different sourcing channels. We also discussed some of VirusTotal functionalities and gave an example on how to leverage them. We tackled what are the different modules to create a profile from sourcing channels, in which later on we could use as an identifier in querying our database. We discussed how we keep our data using Elasticsearch and Kibana for monitoring and data management. We also cite some example on our use case on how we can transform data visualization into actionable intelligence. I believe that hunting for what we have missed is more important than what we have seized. Sometimes hunting for threats that we have missed will give us an opportunity to improve our current process, develop new tools, or upgrade the current ones. Monitoring your data through dashboards or graph will help identify threat movement and discover what we lack in our current system. So we came to the end of my slide, and I hope you had an idea on how we find potential threats. Maybe you have learned a thing or two on what you could add to your hunting process. I would like to end my presentation by sharing some of my learnings in my years of working with the threat hunting team. First one is evaluate your sources. Identify if it's a good source. Does it have normal files? How about adware or other unwanted information that could add noise to your data? If the answer is yes, can I filter it? Is it a duplicate of my other sources? Is the data robust? Is it free or is it worth the cost? Does it support automation? These are some of the important questions to keep in mind when choosing your sources. Next one, automate what you can. Nobody likes doing repetitive tasks. It hinders you from taking on new tasks. I remember when I was still a new engineer in Trend Micro, I could only handle 50 malware samples for manual analysis, and that is for a 13-hour shift. In threat hunting, it is expected to encounter a volume of data for processing, which is impossible to process manually. So automate analysis, automate sourcing, and automate data visualization. Next is collaborate. Hunting is never ending. because threat actors always find new ways on how they can make money. They too collaborate with other cybercriminals for malware services, such as distribution and encrypting services. Always be on the lookout for new projects or research from other team members that you could incorporate to your current tasks. Next, record your hunts. It is very important to document every threat hunt you have performed. Keep a record of the tools used, reference materials, and steps that you have taken. There may come a time that you will need to revisit your notes when encountering similar malware. Techniques or sharing your learning to other parties. Never stop improving, whether it is your hunting process or your technical skill. It is important for threat hunters to stay vigilant and prepared. Cybercriminals are always on the lookout in finding new ways to penetrate secure systems. Take time to undergo training and attend conferences such as Black Hat, DEF CON, and of course Decode. And with that, I hope to see you again next year. Thank you.